Alright guys, so we're going to start reviewing for the second test of the second quarter. Number 1, it wants to know when the expression is undefined. Undefined is when the denominator, so this 2x squared minus 9x minus 5, is when the denominator equals 0. So this is a quadratic, so you have 3 ways that you can solve it. You could do quadratic formula, you could do completing the square, or you could just factor it. So if you do master product, that's what I usually do. But if you do master product, you should end up with 2x plus 1 times x minus 5 equals 0. You set up your t-chart, so you get x is equal to negative 1/2 and x is equal to 5. So if you plug negative 1/2 or 5 into the expression, you're going to get a divided by 0, which is going to be an error message in the calculator. You cannot divide by 0. For numbers 2 and 3, simplify the rational expressions. So to simplify fractions, you see what the top and the bottom both have in common. So to do that, you have to actually factor it. So x squared minus 9 is x plus 3 times x minus 3 using the difference of two squares, divided by 2x squared plus x minus 15. If you do master product, again, I'm not going to do it. We should know how to do master product. You should get 2x minus 5 times x plus 3. So the x plus 3's are what they have in common, so that gets crossed out. Your answer is x minus 3 divided by 2x minus 5. So these two expressions, they're equivalent. They're equal to one another. It's just that the one in blue is in simplest form. Same thing for number 3. To factor the top of this, you get 2 times x minus 5 divided by 25 minus x squared. You would do the difference of two squares. The square root of 25 is 5, so that comes first because 25 comes first. And the square root of x squared is x. You get 1 plus, 1 minus. Now, x minus 5 and 5 minus x, I know you want to just cancel them out right away, but remember, they're opposites and subtraction is not commutative. So when you do cross them out, you have to replace one of them with a negative 1. I personally always put the negative 1 with the top polynomial, but so 2 times negative 1 is negative 2 divided by 5 plus x is your answer. Numbers 4 and 5, determine the result when f of x is divided by g of x. Express the result in this form. So this is just the quotient plus the remainder over the divisor. Okay, so this is your long division. So for number 4, you're dividing by 3x plus 1, and the dividend is 3x to the third minus 29x squared minus 16x minus 8. So you're not missing any terms in the dividend, and everything's in descending order, so you can just go right ahead and do the long division. So 3x to the third divided by 3x is x squared. I multiply that by the 3x plus 1. That gives me 3x to the third plus x squared. I put this in parentheses and I subtract. 3 minus 3 cancels. Negative 29 minus 1 is negative 30 x squared, and the negative 16 x gets brought down. So now I do negative 30 x squared divided by 3x, and I get negative 10x. Multiply that out, I get negative 30 x squared minus 10x. I put that in parentheses and I subtract again. Negative 30 minus negative 30 cancels out. Negative 16 minus negative 10 is a negative 6x, and then this minus 8 gets brought down next. Negative 6x divided by 3x is negative 2. Multiply that out, I get negative 6x minus 2. Put that in parentheses and subtract again. Final time. Negative 6 minus negative 6 cancels. Negative 8 minus negative 2 is a negative 6. So then my result is x squared minus 10x minus 2 plus negative 6 over 3x plus 1. So just a few things to make note of. So that's all that the question wants, but I just want to make sure that we're good for our test. Because you get a remainder of negative 6 and not 0, 3x plus 1 is not a factor of 3x to the third minus 29x squared minus 16x minus 8. And then the other thing I want to make sure we're good with is that this function here will contain the point, ready? So 3x plus 1 equals 0. you get equals 0. You get x is equal to negative 1/3. So it contains the point negative 1/3, comma, the remainder is negative 6. Okay? You're going to use that in a second with 6 and 7. Number 5, same idea. So you're going to do long division again. So 8x to the third plus 30x squared plus 3x minus 1. And you are dividing that by 4x plus 1. So 8x to the third divided by 4x is 2x squared. I multiply that out. I get 8x to the third plus 2x squared, parentheses, and subtract. 8 minus 8 cancels. 30 minus 2 is 28x squared. Plus 3x is brought down. So now I do 28x squared divided by 4x is plus 7x. That gives me 28x squared plus 7x, parentheses, and subtract again. 28 minus 28 cancels. 3 minus 7 is negative 4x. Bring down the negative 1. Negative 4x divided by 4x is negative 1. So that's negative 4x minus 1, parentheses, and subtract. Negative 4 minus negative 4 cancels. Negative 1 minus negative 1 also cancels, so you get a remainder of 0. Because you get a remainder of 0, 4x plus 1 is a factor of 8x to the third plus 30x squared plus 3x minus 1. So you do have to write your result is 2x squared plus 7x minus 1. You don't have to write plus 0 over 4x plus 1 because that would just be 0. And then also, so that's the answer to the question. But just to make note, f of x contains the point negative 1 over 4, comma, 0. Okay, so we're going to use that, the whole point thing, for numbers 6 and 7. Determine the remainder when f of x is divided by x plus 2. You can do long division on number 6 if you want. You would just need to put a placeholder in. See how there's no x squared? So you could put a placeholder of plus 0x squared. That way everything's in there. Okay, or you can just do what we were just talking about. So the remainder is the y value. So we want to know the remainder when it's divided by x plus 2. So x plus 2 equals 0. So the remainder is the y value when x equals negative 2. So negative 2, comma, that, whatever that is. So I would do f of negative 2 is equal to 5 times negative 2 to the third minus 8 times negative 2 minus 1. That gives me negative 25. So the remainder is negative 25. Okay? Again, you can go through and do the whole long division if you want to, but you really don't need to because I don't want to know the quotient. I just want to know the remainder. Number 7, you can't do long division because you don't have the equation. Really, this is just a parabola shifted down 3 units, so you could do long division if you get the equation, but that's neither here nor there. So again, we're dividing by x plus 2. So the remainder is the y value when x equals negative 2. So I go to negative 2, and I look at the y value. Right, that's where the point is. That y value is 5. So that means that the remainder is equal to 5. Number 8 is asking for the x-intercepts, to algebraically find the x-intercepts and then explain the multiplicity. So if you remember, the multiplicity deals with the exponent when it's completely factored. So the x-intercepts are where the y value equals 0. So I have 0 equals 8x to the third minus 12x squared minus 18x plus 27. So I'm going to try to factor this. This first 2 has a GCF of 4x squared, and I'm left with 2x minus 3. Then I have a GCF of negative 9. I'm left with 2x minus 3. So 0 equals 2x minus 3 times 4x squared minus 9, which can be factored further using the difference of 2 squares. Right, the square root of 4x squared is 2x. The square root of 9 is 3. and then 1 plus, 1 minus. So this 2x minus 3 times 2x minus 3, for the sake of the multiplicity, I'm going to write this as 2x minus 3 squared times 2x plus 3. Okay, so this the first factor, this gives me a 0 at x equals 3 over 2. And this one gives me x equals negative 3 over 2. But if you remember, for intercepts, you have to write those as coordinates. So the x-intercepts are 3 over 2, comma 0, and negative 3 over 2, comma 0. If you don't write it as points, you're going to lose credit. You have to write it as a coordinate, x, comma y. And then also the multiplicity. So x equals 3 over 2. This had a multiplicity of 2, which is even, which means it will be tangent. This is not the answer. This is just going to help us organize. And then the other one, 2x plus 3, is to the first power. So this is odd, which means it's going to cross. Okay, so that helps us organize, but then my final answer, I'll write this over here, at x equals 3 over 2, the multiplicity is even. So f of x is tangent to the x-axis at x equals 3 over 2. You need to have that. The other one, at x equals negative 3 over 2, the multiplicity is odd. So f of x crosses the x-axis at x equals negative 3 over 2. Okay, I know it's a lot, but you have to have all of those pieces to it because you have to be very specific in your answer. Okay, the next question is the laws of exponent stuff. So the top is not being raised to anything, so this all stays the same. 4x to the third, y to the fourth, divided by 2 is not being raised to the negative fifth. X is being raised to the negative fifth, and y to the negative third is being raised to the negative fifth. So that turns into y to the 15th. This is my negative exponent, so I'm going to rewrite this as 4x to the third, y to the fourth, divided by 2y to the 15th. And then I move this x to the negative fifth up to the top and make it a positive 5. And then from here I get my final answer is 2. X to the third times x to the fifth is x to the 8th, divided by y to the fourth divided by y to the 15th is y to the 11th. That's your final answer. With number 10, determine the focus and the directrix of the parabola. So it's been a while since we've done parabolas, right? This is in vertex form, which tells me that the vertex is negative 2, comma, positive 1. The signs flip. Also, 4p is equal to negative 12, which means p is equal to negative 3. Because p is negative, it's going to be concave down. So I draw it. Negative 2, comma, 1 is right here. And my parabola is concave down. So to figure out the focus, because p is negative 3, I go down 1, 2, 3 from the vertex. So the focus is negative 2, comma, negative 2. The directrix is a line. It's y equals. I'm going to go back up to the vertex right here, and instead of going down 3, I am going to go up 3. Okay, and this line is y equals 4. Number 11, state the transformation performed on f of x and then sketch a graph. So f of x, we have f of x minus 2 minus 3. So the minus 2 inside the parentheses tells me I go to the right 2, and the minus 3 on the end tells me that I go down 3. So to sketch a graph, I'm given the graph of f of x. To sketch a graph of g of x, I'm going to take some of those points and I move them to the right 2 and down 3. So I'm going to take, there's this point here, I'll take these 5. So I move to the right 2, so I'll do this one first, right 2, down 3. This point turns into this. Right 2, down 3. Right 2, down 3. So that's my new vertex. So this is my new parabola right here. Remember, you only go a little bit past the last point that you draw, and you draw an arrow in that direction. And this is g of x. Number 12, so our rational equations. So this is really over 1. The first step is always to factor the denominators. I cannot factor 1 or x minus 5. So that first step is done. Now for my LCD to cancel out an x minus 5, I really only need the x minus 5. So I put that on top of everything. So my new equation, there's nothing to cancel out to start. So this is x times x minus 5. And then x minus 5 cancels. So I have minus 7 equals x minus 5 cancels equals x. So this is x squared minus 5x minus 7 equals x. I subtract the x over. It's a quadratic, so I want to set it equal to 0. And then I have 3 options. I'm actually going to do completing the square because I feel like it's been a while since we've done that. So x squared minus 6x equals 7. Half it, square it, and then add it back. So x minus 3 squared equals 16. I take the square root of both sides. X minus 3 equals plus and minus 4. X equals 3 plus and minus 4. So I get x is equal to 3 minus 4 is negative 1. And 3 plus 4 is 7. You could have also factored. I usually do factor. You could have factored and gotten these answers. Now, if I plug, so let me erase what I crossed out up here since it's so big. I have this x minus 5. Right, in the denominator. So if I plug negative 1 into x minus 5, it does not become 0, so this is a good answer. And if I plug x equals 7 in, I do not get 0 in the bottom. If I get 0 in the bottom, that's when your expression is undefined, and you cannot have that. Okay, 13 and 14 are the same thing as what we just did. So for number 13, when I try to factor my denominators, they're already completely factored. So to cancel out an x plus 2, I need an x plus 2. To cancel out an x minus 2, I need an x minus 2. So now I see what each fraction turns into. X plus 2 cancels. I am left with 3 times x minus 2. And I have plus. X minus 2 cancels. I am left with 2 times x plus 2 equals x minus 2 cancels. I'm left with x times x plus 2. So this equation is now 3x minus 6 plus 2x plus 4 equals x squared plus 2x. So this is 5x minus 2 equals x squared plus 2x. So 0 equals, I always want to set it equal to 0, x squared. When I subtract the 5x, I get negative 3x. And when I add the 2, I get plus 2. I'm going to factor this. It'll turn into x minus 2 times x minus 1, which gives me x is equal to positive 2 and x is equal to positive 1. When I plug 2 into the denominators, it is undefined, so x equals 2 gets rejected. Only answer to number 13 is x equals 1. Okay, again, if I don't do that, I will lose some credit. Okay, pause the video if you need to. I'm going to erase what I just wrote. That way I have space for number 14. All right, for number 14, again, I don't even have to factor the denominators again, right? Because x minus 1 does not factor and x plus 1 does not factor. So my LCD is going to be x plus 1, x minus 1. Okay, so I put that on top of all of them. For the first fraction, x plus 1 cancels. I am left with 2x plus 5 times x minus 1. So it's a little tougher now because I'm going to have to double distribute. Plus x minus 1 cancels. I have 3 times x plus 1 equals x minus 1 cancels. X plus 2 times x plus 1. Now I multiply everything out. This gives me 2x squared plus 3x minus 5 plus 3x plus 3 equals x squared plus 3x plus 2. So this side is 2x squared plus 6x minus 2 equals x squared plus 3x plus 2. When I subtract, so 2x squared minus x squared is just 1x squared. 6x minus 3x is plus 3x. Negative 2 minus 2 is negative 4 equals 0. I factor it. It turns into x plus 4 times x minus 1, which gives me x equals negative 4 and x equals positive 1. But again, when you plug 1 into the denominator, 1 minus 1 is 0. This gets rejected. Only answer to 14 is x equals negative 4. Number 15, we have a work problem. Nathan takes 50 minutes to finish shoveling, and when he works with his sister, it takes him 20 minutes. So this is my equation. Nathan, to shovel the one driveway, takes 50 minutes, plus his sister, we don't know, equals, it takes both of them together, 20 minutes. So his sister's 1 over x. You can do 50 times 20 and get 1000x as your GCF, or you could also just use 100x. You still get the right answer though, either way, as long as you do it correctly, obviously. So 100x divided by 50 is going to be 2x, plus 100x over x is 100, equals 100x over 20 is 5x. So 100 equals 3x. I divide by 3. I round to the nearest hundredth of a minute. 33.33 minutes is how long it takes his sister. And last one, number 16. A model airplane takes off and a ball is launched from ground level. So the airplane is A of t and the ball is this. We want to know if they collide. So if they collide, you get positive real values when you set them equal to each other. If you get negative, you cannot have negative time. And if you get imaginary, you can't get imaginary time either. So the equation that I'm going to write, I need to know when they are equal to each other. So negative 16t squared plus 45t. So this is a quadratic. I set it equal to 0. So negative 16t squared plus 30t. I take out a negative 2t. I get 8t plus 15. I'm sorry, 8t minus 15. Minus 15. So this, I set up the t-chart. Negative 2t equals 0. So I get t equals 0. This is from right before they're launched because they're both being launched from the ground. And then 8t minus 15 equals 0. When I solve this, I get t is equal to 1.875 seconds. Okay, so they will collide, and they will collide after 1.875 seconds. Or you could write 15 over 8 seconds. Okay? Extra help is on Tuesday after school if you still have any questions.